G'day and welcome to the second video of the normal distribution. In the first video I showed you how to use the confidence intervals, like we've seen before, to try and work out the percentages between 1, 2 and 3 standard deviations either side of the mean. In this video I'm going to show you how to use your calculator in order to get these answers exactly. So you can use your calculator for all of these types of questions. Sometimes they'll ask you questions that don't use exact answers, so they won't be exactly 1 standard deviation either side of the mean. It might be a couple, or it might be 1.3 standard deviations either side of the mean. But the way that we do this on a calculator is we need to use the probability distribution. So if you go to a calculator page and then you push menu, it'll come up with a whole bunch of things. We go into probability, we go down to distributions, and we find normal CDF. We never use normal PDF, which might get a bit confusing later on when we do binomial PDF and CDF, but we only ever use normal CDF, I should say. So I push enter on that one. Now ask me for my lower bound, my upper bound, my mean, and my standard deviation. So if I just go back to the question itself, I know that the mean was 40, so I can type that in, and the standard deviation is 1.5. And my lower bound, in this case, my lower bound was 38.5 and 41.5, so I'll type that one in as well. Oh. And then I just simply push OK, and it tells me 0.6827. It's correct to 4 decimal places. Now, when I did that, when I did it without using a calculator, I got 68% because it was 1 standard deviation either side of the mean. But when I did it with the calculator, I ended up getting something similar to that. This was a more exact answer than the other one. The other one was only an approximate. So I guess you can use your calculator to go back and do that, or you can actually just change the numbers up here on the normal CDF. So for example, if I now wanted to find out what 2 standard deviations either side of the mean, I could just change this to 43 and to 37 and push enter. As long as you know what you're doing, you can just change those numbers. If you're worried, you can just push menu 5 and then find it out from there. Okay, so now I want to talk about how to apply the normal distribution to certain things. Sometimes we need to find the probability between 2 particular items, like we've done in the past. And then sometimes we're actually given the probability and we need to find out the value of the x value that gives that particular probability, and I'll explain that a little bit later. So if I've got this particular case here, I've got year 10 students complete an endurance task. The times taken to complete the task are normally distributed with a mean of 15 and a standard deviation of 2 minutes. Find the proportion of students who complete the task in less than 18 minutes. So what I would do in order to get full marks for this on the test or the exam, I draw a little diagram showing what I'm actually trying to find out. 18 is there, and then I signify that it's x, and then I simply do this on my calculator. I'd write down probability that x is less than 18, and then I'd do this on my calculator. Okay, so menu 5, and then normal CDF. My lower bound was negative infinity. Well, there is no lower bound, so I guess I can just leave it at that. My upper bound is 18, and my mean was 15, and the standard deviation of 2. And I'm going to push OK, and I get 0.93319, which is exactly what I had over there. Okay. So now students who complete the task in time between 13.5 minutes and 17 minutes are classified as having average fitness levels. So I want to find the probability of a student selected at random being classed or classified as having average fitness. So it's simply just, I draw the diagram between 13.5 and 17 is what I'm after, and then I type, I write this down, the probability of 13.5 x and then 17. It doesn't matter whether I've got less than or equal to for a continuous probability, but I just put all of that on my calculator. This time I'm just going to change here. So 13.5 and 17, and I end up getting 0.6147, which is what I had just there. Okay. Then C, find the probability that of a student with average fitness completing the task in less than 14 minutes. So this is actually a conditional probability because I know that they're an average student, or sorry, a student with average fitness. but then I'm told that I'm asked to find out the probability that they finish it in less than 14 minutes. So I know that they finish it between 13.5 and 17. What's the probability that they finish at less than 14? So essentially what I've got for this particular case is I've got bigger than 13.5, oh, that's 13.5, but less than 14. All over between 13.5 and 17. Okay, that's essentially what I'm after. So I can do that. I already know what the 13.5 to 17 is. Now I need to find 13.5 to 14, and that's that. So it ends up being this figure here divided by this figure here. Oh, I didn't do the divide sign. I'm actually going to do it a slightly different way anyway. I'm going to say that divided by this, and I don't need to push Control Enter because it always gives me a decimal anyway. So it ends up being 0.133. So 13% of the average fitness people, they actually complete it less than 13.5. Sorry, bigger than 13.5, less than 14. Okay, that doesn't mean that people who finish at less than 14 minutes are actually 13%, because that's only true for the people with average fitness levels. Now this last one is actually in reference to this equation here. So sometimes we're given the probability and we actually need to find out the value of x that corresponds to that probability. So here I know that the students in the top 10% are placed in the elite sports class, and I need to find the slowest time required to be placed in this class. The reason it's the slowest time is because it's better to finish it quicker. So therefore, here's the top 10% over here, rather than the top 10% being up there. So I should expect a number lower than the mean. If the mean's 15, I should expect a number a lot lower than the mean. So what I do is I draw a diagram, and again I put x down here, and I signify the percentage, which is 10%, and I signify this c value. I don't know what it is, it's an x value, but I'm just going to put a random letter c, or any letter really. I'm going to put c. So the probability that x is less than or equal to c is actually equal to 0.1. I got told that up here. To work that out on the calculator, I simply do menu 5 again, but this time instead of doing normal CDF, I'm going to do the inverse normal. This means that I've got the percentage and I'm wanting to find the x value rather than having the x values and trying to find the percentage. It asks me to find the area. Now we need to be really careful with this one. It asks for the area from the left hand side, which means I have to give it from here. If I had the other, if I had the top 10%, or the slowest 10%, if I had it actually up here, then I wouldn't be able to put in the area of 0.1. I would actually have to put the area of 0.9 because it asks it from the left. Okay, but for me, I'm going to put 0.1. My mean is 15 and my standard deviation is 2. So therefore, 12.44 is the slowest time that students can complete the endurance task in order to be considered in the elite sports class. Okay, so that's how to use a calculator to find both the inverse normal and also the normal distribution as well. So thanks for watching. In the next video, I'll have a look at the standard normal distribution.